Good old days when radios crackled. Making a trunk call was like a Burke and Wills expedition. The only link between Perth and Adelaide was by telegraph. Few telephones were automatic. Words like television, computer, satellite, electronics had different meanings or hadn't been thought of. Research into communications was a humble affair. In the skeptical 70s, we take it all for granted. The facsimile transmission of whole newspapers, heartbeats by telephone, men on the moon. We remember what was, we know what is, but to question what might be is the task of these people, the staff of the research laboratories of the Australian Post Office. For 400 men and women, scientists, engineers, technical people, theirs is a world of hard facts and painstaking research. A world where tomorrow is now. Solid state and quantum electronics, transmission systems, systems development, laboratory instrumentation, satellites, chemistry and metallurgy. These represent many fields of investigation, but in this film, it is possible to touch on just a few of these activities.
She was waiting at my lawn. 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 She was waiting at my lawn.
Telephones are so much a part of life that we seldom consider the trials they must undergo before installation in our homes and offices.
She was waiting at my lawn. 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 She was
Some of the tests held in soundproof booths and listening rooms established the loudness and clarity of reception.
She was waiting at my lawn. She was waiting at my lawn.
22.
When do you expect to get back? I will wait for you in the drawing room. I use the room while you are away. I thought he might be one of your friends.
In other tests, selected groups are used to gauge people's preferences for different types of telephones.
There was a heavy mist in the mountains. I thought you might have seen it. Do you mind if I sleep on the sofa?
To ensure consistency of results, electronic equipment takes over the role of the human voice and ear and is able to detect small changes in performance. Two rooms with entirely differing characteristics play their part in measuring the performance of telephones, in addition to their use for the testing of other types of equipment. The anechoic room with sound-absorbing walls is completely devoid of echo, whilst the reverberant room, with its walls and ceiling of smooth concrete, sharply reflects all sounds. From the study of these tests has grown an understanding of the types of telephones that will meet the various needs of the community.
At the third stroke, it will be 11, 41 and 50 seconds.
Time is important to all of us, but to none more so than the surveyor working in the remote areas of this continent, who is dependent on a precise knowledge of time if his painstaking work is to result in maps of the required accuracy. The precision pinpointing of his location depends on the pulses of a time signal.
This is an Australian Post Office standard frequency and time signal transmission from VNG Lyndhurst, Victoria.
Accurate to 1/10,000th of a second, the signal originates in Melbourne at the frequency and time standard equipment controlled by the research laboratories. Apparatus, including this rubidium vapor unit, provides the standard of frequency and is associated with other equipment generating time scales of high precision. From here is controlled the familiar speaking clock time of day service in each state.
It will be 11:43 precisely.
The accuracy of the complete installation is checked daily for consistency within its different clock systems, while the standard as a whole is compared with that of similar organizations around the world. This ensures precise frequency and time references for seismic and geophysical exploration teams, observatories, universities and the armed services, in addition to post office research groups. A corona discharge makes a spectacular display. It can be likened to a prolonged lightning flash. But phenomena of a similar nature, known as plumes, have caused damage to high-power, high-frequency aerial systems, such as those of Radio Australia. These electrical discharges erupt from the aerials at irregular intervals, and if allowed to continue, can damage the aerial by melting the copper elements. A temporary measure was adopted of switching the transmitter equipment off for a few seconds at one Radio Australia station. This would allow the plume to extinguish itself, but the procedure could not be considered satisfactory until some means of automatic plume detection was devised. The research laboratories have developed a system using sensing units, which are strongly affected by the ultraviolet present in plume radiation. The first appearance of a plume causes a sudden surge in the ultraviolet. Picked up by the sensor, this indicates when the aerial power must be briefly switched off to quench the plume at the outset. Meanwhile, laboratory staff continue with experiments aimed at providing a clearer understanding of the causes of plumes, and which one day may lead to a complete elimination of this worldwide problem. Research work often takes the staff far from the laboratories in Melbourne. Since 1949, teams have been in the field studying propagation problems associated with the now familiar microwave radio systems. In propagation testing, temporary towers are erected and a series of test signals are passed between them. These trials have shown that great care is necessary in the siting of the towers in some difficult regions, such as desert areas, to ensure that the flow of messages between antennas is not unduly affected by atmospheric conditions. A study of the measurements recorded by automatic equipment during extended periods has provided considerable information on the significance of aerial height, position and length of path, and operating frequency of the system. As the next decade may see the introduction of a communications satellite system for Australia, preliminary studies have included an investigation of the effect that rain has on microwave signals above certain frequencies. In an area of North Queensland, known for its heavy rainfall, a solar radiometer has been set up, which uses the sun as a source of radio emission. The antenna is turned automatically throughout the day so that it remains directed towards the sun. The signals reaching the antenna are passed to a receiver and are measured. Recordings show the attenuation or weakening of signal strength during rainy periods. The results of these tests, carried out in various parts of Australia, will assist immeasurably in the planning of new communications links. But even these systems could be outshone in years to come. For then your words, born on a beam of light, may flow through a glass fibre. This could be the outcome of the development by the CSIRO of novel low-loss optical fibres. These are hollow silica tubes, slightly thicker than a human hair, yet filled with a fluid. Unlike a wire system which carries its signals electrically, an optical fiber transmits a beam of light. At present, the point sources of light are provided by lasers or light-emitting diodes. In the experimental setup, the beam of light is directed onto a glass tube holding one end of the fiber. Modulated by the speech patterns or other signals, the fluctuating light beam is transmitted through 1,000 meters of fiber on the drum and is detected at the far end, where it may be converted to its original form. This new medium is capable of transmitting more information than present-day systems, whether it be telephone conversations, data signals, or radio and television programs. Many experiments and much development, however, must yet be carried out before the fiber can take its place beside existing systems. Some of the problems to be solved hinge on the repair of breakages, the manufacture of fibre in the long lengths required for communication purposes, and the feasibility of binding a number of fibres into one cable. As a first step, coating of fibres with a plastic has been successfully accomplished. The conclusion of these investigations will determine whether one day our cities and towns may be linked by beams of light. The telephone exchange, too, will undergo dramatic changes to meet tomorrow's needs. Throughout the years, they've relied on devices such as relays and mechanically operated switches to make the necessary connections between the caller and the number he has dialed. But these cannot easily provide all the control facilities that are essential as the network becomes larger and more complicated. In addition, the time involved in making the step-by-step operations necessary for each of the many simultaneous phone calls may create delays in the system. The research laboratories, together with research establishments in other countries, have conducted trials of a scheme to overcome these problems. Known as Signalling System Number 6, it is a more efficient means of linking telephone exchanges, and though designed principally for international use, is representative of the system type which may be eventually installed in Australia. In the existing telephone network, the dialing pulses and the voice signals are carried on the same line. But in the new system, dialing signals are confined to a single data link between exchanges, while the conversations pass along other channels. The experimental exchange is controlled by a processor or computer, which basically has the same tasks to perform as a switchboard operator. It scans the lines of the exchange, detects new calls, and then sets up the necessary connections for as long as required. To enable all the logical and switching tasks to be carried out, instructions are punched onto paper tape, which is then read off and fed into the memory of the computer as a stored program containing over 15,000 instructions. During testing, normal phone calls are routed through the installation, in addition to simulated calls originating in the exchange. A lighted panel gives an instantaneous indication of the processing of the calls, whilst a teleprinter, wired into the system, is used to carry out testing and to record any faults diagnosed by the computer. The experience gained in research projects such as this has already yielded many valuable insights into signalling systems and the economics and technical operation of computer-controlled exchanges for the Australian network. And so it goes on in this world of probing, proving, delving, doubting, discovering. Old avenues will close, new ones will open, so that tomorrow will give us the fruits of their labours, when their efforts in these many fields will be of real benefit to Australia and Australians.